Discussing how to evaluate nth roots and using rational exponents. So the first thing we want to do is look at some vocabulary. Let's get the mouse working for us. Perhaps not. There we go. So our first vocabulary terms are, when we talk about the nth root of a, we're talking about for an integer that is greater than 1, if b to the nth power is equal to a, then b is what we call an nth root of a. So for example, if we have 2 to the third power, that equals 8. So if I want to find the third root of 8, that would be 2. So the nth root, the third root, or the cubic root of 8 would be equal to 2. An nth root of a is written as what I just wrote here. Then in algebraic terms, let's rewrite it. A goes on the inside, and then our exponent would be n. And we call this the index of the radical. The radical sign, again, is this little division with a kicker looking symbol. And then if we want anything other than a square root, we would put some value on the inside there. And that would tell us what nth degree or nth root we're taking. All right, let's take a moment to look at this chart. In fact, you'll probably want to pause the recording so that you can record down some of this important information. What this is showing us is that if we are trying to find the nth root of something, and n is an integer, and a is a real number, so some random real number, this is how we can figure out what kind of roots we're going to have, what kind of answers we're going to have. So if our, let's undo that here a moment. There we go. Let's get the pen working again. So if n is an even integer, so 2, 4, 6, 8, whatever, and we want to figure out what the root is, well, we have to look at what is on the inside. So if I have the fourth root of a, whatever a is, this is what we're talking about. So if a is less than 0, there are no real roots. So for example, think about when we're trying to find the square root of a negative number. We know that now these are imaginary numbers. So no real roots. We only want real roots at this point. If the the nth root of 0, if your number on the inside of the radical is 0, then the root would be 0. This is true whether it's even or odd, because you have it here as well as here. So if 0 is the inside number, the root's going to equal 0. Now, if a is greater than 0, if your exponent, or your root, was even, then you're going to have the positive or the negative. All right, so you got to look at that positive or negative sign. Now, notice that in order to take it from the radical into the exponent, the rational exponent, we take whatever is going on here with the n, and we put it as a fraction. In the next couple of slides, this will make a little bit more sense. Now, if your root is an odd number, then you're only going to have one real answer. If the a on the inside is negative, then it's going to be just whatever that sign is. Generally speaking, if a is negative, then the root is also going to be negative. And then if it's 0, of course it's 0. And then if a is positive, your root is going to be positive. So let's take a look at a few examples. So get back into our mouse mode here and go on to the next screen. All right, so we want to figure out what is the 6th root of 64. So we write this generally using our radical sign we can write it like this, or we can write it like this. But what we're really trying to think is what, so some random letter B, raised to the 6th power is equal to 64. Well, we know from our powers of 2 that 2 to the 6th power is equal to 64. But so is negative 2 raised to the 6th power, also equal to positive 64. So the 6th root of 64 is going to be equal to positive or negative 2. So 6 is an even number. A was greater than 0, so that tells us we have 2 real solutions. Looking at example B. N is equal to 5 and A is equal to negative 32. Well, this is an odd number, so we already know that there's going to be one real solution. And then A is less than 0, so we know our answer is going to be negative. Well, again, going back to our powers of 2, 2 to the 5th power is equal to positive 32, so that's not our answer. But negative 2 to the 5th power is equal to negative 32. So the 5th root of negative 32, make this look like a 5, or not, is equal to negative 2. Now, of course, we all know that we're not going to be doing this by hand all the time. We just want to learn some basics so that we know how to manipulate it on the calculator. So let's take a look here off the screen so we can see it. Here's another slide where you may want to pause the recording so you can copy down the important information. You've already seen me do it a little bit with just the basic cube roots, where if I had the 3rd root of A, rewriting it as a rational, where 1 over n. But now we're saying, well, what if you have something other than 1? What if you have a to the 3/2, or a to the negative 4/5, right? How do we rewrite this? And we seem to be missing some information on the second one. The line has disappeared on us. Should be right there. Actually, we're missing all sorts of information. Let's finish up this slide. 1 over n root of a raised to the nth degree, and a cannot equal 0. For some reason, when I copied over the slide, it didn't copy over the rest of the information. So here's the rest of the formula. So you have this one right here, and then you have what it is if your exponent is negative. So like I said, pause if you need to copy it down. If not, we are moving on. All right, for our 6th slide, we're going to evaluate example A, 9 to the 5/2, and example B, 27 to the negative 1/3. So for example A, I rewrite this as the square root of 9 taken to the 5th degree. Now, we don't need to write the little 2 there when our denominator is 2 of a rational exponent. Here's our rational exponent, it's a ratio, it's a fraction. If it's a 2, we don't need to write the little symbol inside the radical sign. We already know what that is. Again, we always assume the positive when we evaluate, unless we're solving an equation. This is simplifying an expression. There's no variables here. So this becomes 3 to the 5th degree. So continue to solve this out. You can use your calculator, or you can do it by hand. So 3 times 3 times 3 times 3, which equals 243. All right, example B. We have 27 to the negative 1/3, so this becomes 1 over 27 to the 1/3, which is 1 over the cube root of 27. And so think to ourselves, what times itself 3 times would equal 27? And that would be 3. So our answer is 1/3. All right, you may want to re-look at these examples just to see. But try it on your own, or not. Silly computer. Clear this off. Try these examples on your own. You have 4 problems to try. Read the instructions, pause if you need to. Now, hopefully you've taken some time to pause and answer the questions. Here are the solutions. And if you have any questions about these 4 problems, we will discuss them in class next time. This concludes our first lesson. We'll finish up the next 3 examples on the next recording.